Okay, hello. So this lab is a hilarious mess of a lab, I think, in a nice way. No, don't take that the wrong way. I think it's great. So because this lab was scheduled for Mondays, we had all those holidays, so we missed out on things. And so I have this like big tooth lab that I like to do that we totally don't have time for and we're not gonna do. And then we have the paper reading and like doing the discussion group in comparative anatomy. That's a really important part of this class. And so I realized that today, which is the start of reproduction week, lecture tomorrow and lecture on Thursday, it's all reproductive stuff. Dr. Pradhan is going to come in, Devlina Pradhan, and she's going to talk about sex change that she observes in fishes and like the social and physiological behavioral things that happen in fishes. And then of course, for you guys, the anatomical things that happen as fishes transition from female to male in their natural habitats. And so she was going to go. And then she emailed me last week and she's like, I actually can't be there till 2:30. And I was like, perfect. So let's talk about sharp teeth for like an hour. And then she'll be here and we'll talk about sex changes in fishes. So that's what I mean by a mess. Not really a mess. It's a good thing. So here's what's going to happen today. So we are going to have a discussion about the paper. Did everybody do your reading? Always the contingent thing. Do your reading on this paper. So the reason I had you guys read this paper is not only because it's super cool and interesting, I think. I also know all these people. She's like one of my great friends, Megan Whitney. It's so cool for this class because this is taking very, very different kinds of amniotes, reptile line and mammal line amniotes, some extinct from a long time ago, some extinct very recently, and talking about the kind of evolution that we can see in their teeth, looking at both the gross anatomy and the histology. So like cutting the tooth open, looking at the tissues of the teeth. And so I had you guys read this in part because one of the things we think is really important in the biology department for any undergrad, any major in biology, is to have real exposure to the primary literature. This is a brand new paper, brand new findings. Reading these papers, I hope, or I expect, is like challenging. I'm sure you guys got 5 words in and you're like, nope, don't know what that is. And maybe you Google it, maybe you don't. Maybe you push through and you like trying to get the idea like halfway through, it starts to click. I don't know. Part of this is to make you dive into that primary literature, see what you can pull from it. You know, none of this is like content you're supposed to know already or stuff that I'm going to like test you on. It's like to get you exposed to the literature in general. And so I would like to get you guys kind of in groups of like 3 or 4 that are pretty discrete. Can we do that? Can we move around a little bit? So you have like, I mean, this is pretty natural. I don't know how you guys want to break up. So like, you want to do 3, and then you 4, and well, you are 4. Okay, you 3 together. You 3, you 4, you 4. So we kind of like tighten up a little bit. Maybe you guys not being so linear. Okay, so for like 2 or 3 minutes right now, 2 or 3 minutes only, talk to the people around you, your group that you're in. What was the deal with this paper? If you had to say in like a sentence or 2, even if you have like, I have no idea what it's talking about, I have so many questions, I don't get it at all, that's okay. Try for like 2 minutes, tell each other, what was this paper kind of about? Go ahead. It was about teeth, but say more.
Specifically,
well, yeah.
And then they compared the word teeth with Carnivorous, smile, big smile, and thank you. Lord,
Yeah, I was. Yeah, I know which one you with. One has. We call it identical. Yeah, you're doing. It was that thing. Yeah, it was like. And then the little task.
Okay. I'll call you guys back here. So I like what I'm hearing. Sounds like you guys read it. I'm hearing some good conversation. I hear a couple questions that we'll get into. So I'll put a little bunch of stuff together just to get everybody on the same page, and you'll break out to talk some more. So this is like, to me, I don't know. This is when like biological science, and especially something as specific as comparative anatomy, is like at its greatest. Is when people are like, you know what? These things all have sharp teeth. But let's get into it and talk about the details of tyrannosaurs, saber-toothed cats, and these crazy monsters you guys maybe have never heard of before, which are the first like big saber-toothed predators the Earth's ever seen. And like put them all on one paper and not worry about it, because they all have that same inherited anatomy. So don't cringe, but you've seen this slide before. Some of the slides I'm going to put up you've seen before. They'll have this on it. Just to remind you, the vertebrate hard tissue package, every tetrapod, every amniote inherited from a much farther back ancestor, the same sets of tissues. And just to refresh you guys, one of those tissues is called dentin. Your teeth, the white part of your teeth, is for the most part this material, dentin. Dentin's very similar to bone. It has a lot of different components, including a water component, protein component. It's a living tissue and it grows. That's what makes teeth white. You also have on the outside of your dentin in your teeth, you're a mammal, enamel. And so enamel is something on top of dentin that we see in shark scales. It's what we see in like the teeth of all kinds of animals, all kinds of vertebrates from the entire tree of life. Enamel, unlike dentin, is almost completely mineralized. It's not a living tissue. It's almost a crystalline tissue. It breaks, it cracks. Someone in your family cracks their crown. You get a cavity, your enamel is eroded, cannot heal itself. It's just a crystal. You have to get a filling. So there's dentin that's soft and kind of like bone, and enamel that fits on top. Anything from 300 million years ago that's a mammal or a reptile or a dinosaur or whatever all has those same tissues. And so today, you guys read a paper that like really zooms in on like the microscopic structure of those two tissues and the way they interact with each other to make functional shapes. In this case, like murderous serrated steak knives, which is really cool, right? So you've seen this kind of stuff already. You've been exposed to dentin and enamel. I wanted to give you this just to throw it out there. We didn't talk about teeth. We didn't do a teeth lab, so I didn't give you this when we did our anatomical directions, when you guys learned about distal and proximal and medial and lateral. So here's a dog skull in ventral view, and there's that midline you guys have seen before. There were a couple words in this paper. That's why I included this slide, just to get us all on the same page. Mesial is a directional term in anatomy. When you're talking about the tooth row of an animal, mesial is towards the midline. It's not like this towards the midline. It's like following the tooth row, mesial. And then, stupidly and confusingly, distal is the other word. So these are your distal teeth, and these are your mesial teeth. They're also almost on the midline. So mesiodistal was in the paper. They talked about that, talking about which surfaces of the tooth, the serrations, the steak knife kind of things were on. Then there's also two tooth words that I want you guys to know that talk about the sides of the teeth. So the labial side of the teeth is on the lip side. The labial is the outside of the tooth row. And then the inside is usually where the tongue is, in most tetrapods anyway. And so that's the lingual side. So labiolingual is very similar to like mediolateral. Sometimes in this paper, they say the tooth is mediolaterally compressed. You could also say it's labiolingually compressed in that axis, the shape of the tooth. So just a couple direction terms I want you guys to have, because you didn't get them because we didn't get to do a proper tooth lab. But okay, let's talk about cool teeth. So here's a bunch of extremely different amniotes. Something that's related to us, a mammal relative, a big lizard, one of those scary crocodiles that can run really fast, and like something like Velociraptor. talk to each other for a second, which is a dinosaur with feathers and claws and stuff. Talk to each other about the teeth these animals all have, make observations about the morphology, the shapes. Oh. Why don't you go? All right, so can I get some observations about these four vertebrates' teeth?
We were discussing how like Velociraptor has like the serrations on like the outsides of the teeth.
So is this a new word for anybody? Serrations? Like you have a butter knife in your kitchen drawer and there's like teeny little ticks on the butter knife. Those are serrations. And then a steak knife has like very jagged, sharp serrations. So it's these little structures here. And you guys probably know if you've ever used a knife, like if you want to cut through a steak, you can use a butter knife or you can use a steak knife. And these kind of structures, humans inventing it on a piece of metal, animals evolving it in their dentition, allows you to slice through things. So serrations you can see on the Velociraptor. I can actually tell you that all of these animals have serrations. This is not like the crocodiles of today, but there are serrations on these teeth. This little guy here, this is like a zoom in, there's the serrations under the microscope on this tooth. What else besides serrations?
A lot of the teeth are angled backwards.
Angled backwards. So yeah, towards the throat, right? We call that recurved. They curve this way. Can you think of any animals that have sharp teeth that are like, or no, usually it's this way, right? They're gonna grab and then back towards the back of the mouth. So recurved teeth, serrated teeth, what other things?
I thought they were mostly similar in size. Teeth, like
What do you mean by mostly similar in size?
like nothing like saber-tooth canines where they're like massively different.
So what's interesting is like certainly like Komodo dragon has tons of these teeth. They're all about the same size. Some are bigger, some are smaller. Any idea what's going on there? So there's that. That's a good observation. The crocodile is interesting because there's big teeth like on these parts of its skull, where like they're like the actual bone of the maxilla or the premaxilla has like architecture to it. So it's like a little bit of a gnarly, jagged situation in that crocodile. This same thing's kind of true in this mammal relative. The bone itself kind of has a curve, like goes up and down, and then bigger and smaller teeth like are more emphasized then. They're like sitting up on points. That's cool. What else? We'll get back to those small and big teeth on the Komodo dragon later. You're seeing these all from the side. What do they look like from above or from the front?
Some are more bladed than others.
Bladed? What did you say?
Stabby.
Stabby? So you guys are good. You're getting all over it. So this was a word that was like word 3 in the paper. Zyphodont. So zyphodont teeth are laterally, or you could say labiolingually, compressed. So the tooth isn't like this in top view, it's like this. It's very narrow. On the mesiodistal axis, it's long. On the labiolingual axis, it's relatively narrow. They're compressed, they're pointed, they end in points. And then they're serrated. There's edges that are like, got these structures on them that make them look like what you guys might think of as like a butter knife or a steak knife, depending on what kind of knife you use, a serrated edge. So something that I think, just as its own factoid, is fantastic, is that xiphonont teeth have evolved a lot in amniote evolution. A lot of amniotes, mammals, reptiles, have xiphonont teeth. What is the ecology of xiphonont teeth, do you think? Ripping and tearing, probably not cute nuts and flowers, but like other animals. These are meat-eating teeth. And so we've known this for hundreds of years, right? That meat eaters have this suite of characters. Here's a bunch of specific tooth characters that when you see them, you can be like, probably not grinding grass, right? With these teeth. So this is what a xiphonont tooth is. Laterally compressed, pointed, and serrated. So then there's all these like special cases we can get into. Also, this is fun. This is when I went to, I have a couple of pictures for you guys from like when I was gone during Mammal Week. I was in Seattle. This is a giant crocodile tooth. Look at the serrations that I found in the Triassic of Africa. So like when dinosaurs are first evolving in Africa, the big predators are these like land crocodiles. And this is like a great tooth. And I was looking through my pictures for other reasons today, and I saw this and I was like, oh, I'll put that in there. Look at all the serrations that this croc thing has on its xiphonont tooth. Pretty sweet. Okay, so here's a little phylogeny for you guys, just with some context, because I know you met a bunch of animals in this paper and you might be like, I don't know what these are. And this isn't a paleo class, I'm sorry, but here is the geological timescale of the last 500 million years. Here's your earliest vertebrates, or here in the Cambrian. Here's you and me living 0 million years ago, right now in the present. Right now, these 5 animals, including you, are alive on the planet. And here's the phylogeny scaled to time of these 5 animals. Let's do ourselves a favor, even though you probably hate it from the exam. Talk to each other. What, you can label these notes, can't you? Okay, talk to each other. All right, are we feeling good? You guys feel like you got these? I feel like you do. All right, so just in case you don't, I'll throw some on there. So there's our reptilia, right? The lizard, the crocodile, the bird, those are all reptiles. Within reptiles, there's archosaurs, that's the birds and the crocs, sure. Over here is mammalia, we could call it, or I heard some of you saying with that, there's no platypus, there's no echidna. You could also label this theria, that's fine. But on this tree, it's definitely mammalia, there's only 5 animals. Those are the 2 mammals. So, cool. Amniota's back here. So this is cool because you guys can kind of see context for things. Amniotes diverged in this period called the Carnivorous. A bunch of reptile evolution happens in the beginning of the Triassic. These mammals split from each other in the Cretaceous, maybe the Jurassic. I think Cretaceous, some people don't. But right about here, this is time calibrated. It's giving you guys a little bit of a sense of the space throughout Earth history when these actual splits really did happen. But okay, in this paper, we weren't talking about any of these animals. On one side of amniotes are all the things, including extinct things, that go off here that do not make it all the way. So you guys didn't learn the names. Everything on that side of amniota is called Sauropsida. You guys also might hear Diapsida. Remember the 2 holes in the head? It's kind of very similar. Do not worry about the difference. And then the other side is Synapsida. And that's everything that's on our side of the tree. So closer to mammals today than anything else or any extinct things. There's a lot of stuff here. Look at this lineage. It's very long. So from the split with reptiles until we actually get to the diversity you guys think of as fuzzball milk drinking mammals, there's a ton of time. And there's a bunch of cool things that fit in there. Some of them are in this paper. So there's where we put some dinosaurs. Dinosauria is a monophyletic clade within Archosaurus, within Reptilia, within Amniota. T-Rex goes with the flamingo. The long neck one goes outside the 2 of those. That's dinosaurs. And then on this side, here's a bunch of synapsids, mammal line animals that were in this paper. This paper talked about this animal, which is a real celebrity. You probably have a toy of it, or you did. Maybe you don't anymore, but you might have. Dimetrodon with the big sail on its back. It's always sold as a dinosaur, but it's actually on our side of Amniota. Gorgons, which are the big, scary first evolution of saber-toothed teeth. That was the big focus of this paper. There's where they go, a closer common ancestor with mammals than either one has with something like Dimetrodon. And then we talk about saber-toothed cats, which are way up here, way up in their mammal tree, and they're cats. They're normal cats. They are related to all the carnivores and all the cats and you. So there's your placentalia as part of this tree now. So I hope that orients you guys with like the knowledge you already have about biodiversity and then where some of these animals that are talked about in the paper actually fall out on the amniote tree. What I want to point out though is all that evolutionary time that I mentioned a second ago, this huge lineage. I gave you so many characters for mammalia in class, fur and milk, but one of them was heterodonty. And you don't go from a mouthful of like lizard teeth that are all the same, and then you have a baby that's got all kinds of teeth. It's an evolutionary change. And so today, marsupials and placentals have these different kinds of teeth, but the evolution of those teeth happens in these fossil lineages, which are really cool and let us get after a bunch of really interesting adaptations for why these different teeth, heterodonty, evolved within mammals. Just because we didn't have a tooth lab, here's some really basic stuff. Here's 3 mammalian skulls. This is the dog, this is the deer, this is the person, with general dietary vibes, carnivore, herbivore, omnivore. All these mammals share the same dentition ancestrally, that they have been modified to fit the ecologies they have. So you and this deer and this dog have been incisors in blue, canines in orange, premolars in yellow, and molars in this like purpley brown color. So you have these same teeth. This tooth you have that's like, you know, when you're a cool vampire for Halloween is homologous with a dog's tooth that you might see when your dog snarls at you or your cat hisses at you. Those are homologous. I'm giving you this slide only because, as far as I know in this class, we've never talked about this, and so I have to give it to you at least once. But when we say heterodonty for mammals, this is what we mean. That lizard had a row of teeth that were pretty much the same front to back. A dog has extremely different teeth for extremely different functions throughout its mouth. So do you, so do all mammals. So heterodont dentition. So if we go back here to the phylogeny, we can like use it as a framework for asking really interesting questions. That possum's teeth look pretty much like the dog on the last slide. You know what your teeth look like, and here's that saber tooth. And so what I always think is so cool is these animals in the middle are like inherently awesome because they're sort of upsetting. They are mammally, but not mammally enough. This thing looks like a lizard with like a crazy fan on its back, right? As we get closer to the mammalian common ancestor, we see more mammally features showing up and we get more confident, like, oh, they for sure have fur, they for sure have milk, but there's a lot of true in-betweeners, which are awesome. And so here's an interesting question you can ask. You can just talk about synapsids. And I know for a fact that like the people who wrote this paper, this is where they were starting. Ever since people found fossils of these ancient Permian, before the dinosaurs, mammal relatives that have these giant saber teeth, people are like, oh, cool, saber teeth. I know saber teeth. And they have this fossil, which is from the Ice Age. This is a fossil of a cat. Humans lived with this cat. Our species knew this cat for like many, many, many thousands of years. And this thing is from before dinosaur time. So insanely different. And so the obvious thing to talk about is like, oh, cool, convergent evolution. They both have saber teeth. Sweet. And so there is something probably to the fact that they're convergent. And then this paper dug in a little deeper to get how convergent are they really? You have a common ancestor with this animal before it does with this animal, right? So like, that's really cool. Obviously, there's something to nightmare canines and having that be a successful ecology. I think that inherently is really interesting. So what I want to do is send you guys out to just chat about this paper. I have some questions I'll put up on the board. But before I do that, yes, we will do it. Before I do that, I wanted to just show you some cool stuff. So the reason I thought this would be a great paper to read for teeth is because it was super short. It had saber-toothed cats and tyrannosaurs and gorgons, and gorgons are something I study. So I'm like, oh, you guys will read this for sure. So this is the time period in Earth history that I actually study. So here's the Earth back in the Permian. That's basically what it looks like. That's Pangea, kind of looks like Pac-Man. And I'm not gonna blab, but that's like what the habitats look like. Those are what the kind of animals are. We got the early croc and dinosaur relatives and a bunch of these weirdo mammal relative things, as well as some reptiles that are like super archaic reptiles that have nothing to do with the reptiles of today. Skip through that, skip through that. I just wanted to give you guys a little research scoop because Dave Alito's about to come in and do it too. So when I do field work, I go to places in Eastern Africa, Zambia and Tanzania, and there's also places in South Africa where we actually get all these really awesome fossils. I just wanted to show you some because I think it's cool. That's what it looks like. You're just walking around in the savannah and there's no badlands or prettiness. I mean, it's pretty, but you're just walking around like a grassland and you'll find patches in the ground and there will be fossils there. And that's what we dig up and bring back. So some of them are down at the museum, down campus. A lot of them are in other institutions once we ship them back from Africa. They all will eventually go back to Africa. We don't keep them forever. We're just studying them. But I just wanted to show you guys some real deals. So some of you maybe have seen these before, but I know that's just because you took another class with me. So these are some real fossils. This is what it actually looks like when you find them. Go ahead and talk to each other, see if you recognize anything. What are we seeing here? There they are with scale bars. Is anybody seeing anything they might recognize at all? Not expecting it yet, but you might say something's there. I don't know. And where is the something?
We were talking about how that one on the top, kind of that on the far left of it, kind of looks like a V9 and then three molars leading to the front of the face.
This?
To the right, yeah.
Yeah, sure, for sure. But then like there's a leaf and there's some dirt. Okay, cool. And then there's this here. So this is the front of a face of one of those gorgons with the saber teeth. This is the saber. And then these are some incisors right here sticking out of the rock. This is when we found it the day of, picked it up, took a picture. This is a nice scapula. That's the blade. There's the glenoid where the humerus fits in right there. Hey, look at that. But I think finding fossils is always ridiculous because you don't know it's there until you're like, oh, and then you just realize, just pick it up. It's really a bit upsetting. There's a skull cleaned up. So canine tooth and then the incisors. So there's those incisors. There's that canine tooth. And this is one of those gorgons that's in the paper, which is really cool. We'll skip this one because of time. I always think this one's fun. This like little thing that has all these like weird radial things and has this little bump in the middle. That's from one of those crazy ancient reptiles. That's actually the prey of those animals. Looks like that. It's called a parasaur. People used to think they were related to turtles. We don't think that anymore. They're pretty great. They're successful and they live all over the world, but yeah, they're extinct now. They get disemboweled a lot in paintings of these animals. Sorry. Okay, this is what I really wanted to show you. So this is another gorgon that I found. This is one of my this is my personal best of 2019. But I was walking and I saw this white and this little thing here and this broken piece. So I knew I was looking at bone and I didn't know what it was. And so all I'm doing is like walking around this thing, looking at the ground, trying to understand what it is I'm seeing. Because I can tell there's bone here. This looks like bone. I think all these are just rocks. I scraped some of this off. There's nothing. Okay. And I'm walking around before it starts to click. But that's the eyeball. So it's like literally like looking out of its tomb or just the ground, but it's looking out of the ground, like right back up at me, which was pretty legit. Here's that fossil out of the ground and flipped over. This was in just before COVID. So we got it out in 2019 and just before COVID, this is the other side of that skull. So we covered it in plaster and then flipped it over. So you can see there's the eyeball. Here's the other saber still in the rock and it's still there in the ground. This is before COVID. And then there's my friend who she just found this one. I always think this is a great picture. This is just like a rock, like loose. And she was like, oh, look, and she picks up this rock. And so this is another one of these animals where it's like eyeballs nose, temporal muscles, like up here. This is like the sagittal crest, like when you pet your dog. And it's just like a rock. And it's just like, great. You throw it in the bag, and you take it to the museum, and you're good to go. Which is really funny because people think sometimes it's like finding fossils must be hard, and sometimes it is, and sometimes it's oh, great. Throw it in the bag, take it back. That's called the Erignathus. Anyway, when I wasn't with you guys, this is that same skull as it looks now because it's been getting more prepared. So here's that side. I thought, I can't be more excited about this. I wish I could show you guys in some real way how insane this is to me, that this is how beautiful this is coming out. So you can see the incisors. You can see the nostril up here. Little post-canine teeth, big saber, perfect saber. And then what's so cool, so there's the eyeball that I originally could see. Now that this side has been cleaned off, there's the big saber on this side, which is ridiculous. And then this is so fantastic. That's the replacement saber. So these aren't mammals yet. They do like replace their teeth continuously. Obviously, this one gets replaced much more slowly than the smaller ones. But so it's amazing to think that this, when this animal died, it had an intact saber on one side and like 1.2 sabers on the other side, which is really amazing. And so a big cat, if you saw a lion today, there's no lion that's got an extra canine coming in behind its canine, right? Mammals have only 2 sets of teeth, a baby set and an adult set for the most part. And so these animals obviously have incisors and canines and post-canine kind of teeth like we do. So they have some kind of heterodonty, but they're still a little reptilian in the fact that they're like replacing their teeth a lot, which is very, very fantastic. Anyway, here's that same fossil you saw in the ground on the first slide. And here it is a couple weeks ago when I was in Seattle. It's looking better. It's looking nicer. It's just the face. It's just the very tip of the nose of one of those gorgons. But okay, I just want to show you guys that paper because there's cool stuff. I would like you to please get into your groups again, and we're going to spend a good amount of time here having you guys chat. I want to hear you guys talk about the figures, make sure people understand them, and get into like discussing this paper. I will, well, also, if anybody has any questions, you can definitely ask a question. I also brought you everything, brought you a Tyrannosaur. And I'll come around, but I brought you a saber-tooth. And I brought you a Gorgon from Japan. So I'll put those in the back, but go ahead for now and get chatting about these papers, about this paper, so we can hear what you guys think. Okay.
Which is and it's different between them, or like maybe you don't need as much of like consideration and like hard to if it's constantly like being like it has those super strong teeth. Without reacting, there's no.
Yeah, that's what I would. Yeah, I think that was. I like it more.
And then this.
First, really. I think a lot of them. Yeah. It seems like they're.
Yeah.
Well, that's not like. As well. I like to keep always having gyms,
There's this post
where it plays through.
in your household, like you said, what you have to learn about and the more like the break on. But they're all-
Yeah. What's going on? So
But inside of it's there's different elements. And now here's so they're all curvature. I'm wondering.
What? When.
It's like if you're finished.
Yeah.
So we have like the fact that it didn't have like.
I don't know if it's probably bad. Still eating, right? Actually, wait.
That was
I don't, I think it's gonna, but they have all the, you know, or like the real.
Oh, it's like. So they're dangerous. They think they were in one favors and they're saying that it's not also have a video, like, they're like really challenging.
And I know that, I think these are gonna be diameter. Like they're in the way.
I'm looking at my before. That's what
Yeah, there's a couple of nice. Yeah, so they're playing a pop. Like the. Yeah, you're right by here. Definitely did. So she always. Yeah, but I can do somewhere. That was fun. Yeah. Really.
Definitely like.
Sure.
They're not. Yes.
Reality.
Oh, no.
Like 35 miles. Our people, otherwise, there's an all around. Yeah. That's like. That's science. Well, like the school is already kind of reminds you of bigger people. Very similar.
You say how it works? That is.
Yeah, you guys. Oh, yeah.
Well, I mean, it's just perfect. The track. It's just not. One like slow down. It's not. It would be possible. So I'm going back to everything over and start to pay everybody. It's like, I guess I'm getting this. It's really. It's not good. Yeah, it's really.
While I was first. Came out. Okay, I'm going to like start. Getting it. That was it. I was like. That's okay. Even dry. It's nice. But he's never, he's only been wrong. That's great. Well, probably not, but Viva said no.
There's a part here.
I like blue and and it's still pretty heavy.
That's just probably for like holding on to. It's so much it's like watching it from great years.
And it's really, I don't know.
Those people are gonna share it. Like it's all serrated. All right, sorry, I was doing that stuff. Here's the other question two, or second set of questions I like to ask, and then like you guys want to come stuff back there. Yeah, I got it. I got one down. And I guess they like transfer the real negative.
Yeah. A lot of roof is in there. There's really no it's yeah. It's I really lacked on, and they're you still want to like that one kind of stuff.
They're like, what do they eat?
Yeah, they have but a lot of them, they use it. Okay, I like it.
I can find it.
Yeah. Snakes, no.
That's probably.
Open your mouth. Great job. Oh, yeah.
Well, it's full of armor.
They eat stuff for food, but they just unshape it. Oh, or they like that. I think. Thing like, I feel like you don't really see it. But then I shoot that. But. Obviously, like different. Yeah. Even though they're. Curated. Which is so cool, so it's like, I think that's one of the.
I think
Well, you can like, just an animal, it's like, you can like reconstruct it and have.
Because they have.
but they're not mounted. I think the cooler.
That would be all. Yeah, I I don't know. Yeah.
Let's say.
And then, but one individual. Okay, higher than that.
Go on. Rather than. Now. Like, okay, guys, wait, with me, I'm not.
So what they're.
That's fine.
Pretty easy. I didn't change a lot.
There are some really.
And like the actual like 10 million base pairs, even though.
Yeah, that's a great question.
But they do.
What?
But then that's the thing.
Brains.
I didn't like that.
Rigid.
That was.
You just like.
Yeah, it'll make you like believe in it.
That's what it was. But.
I was. I really essentially did not. I think there's water. I was angry at even. It's usually like in the form of either paper or. Like a big thing about 9. Yeah, everything in China. Like the cool thing I've been showing. It's been being right, so I'm doing most of it. It's so outside. Like a team for. Like a there like that. You got to pull it. Oh, but water. What? Water. I think I got her.
They haven't, you guys haven't seen Saber Tooth yet. Where did water come from? Area everywhere. Well, so the answer is like. It doesn't really have water. It's all of these are that are. These have water, all water. So not necessarily they're water, but I would have to like check. That's what we were saying, but I know that like, during this formation, bombardment is a little cold. But,
So like, it existed formation.
yeah, well, think, okay, the solar system was formed, it's immense, right? But another living system that was like create pretty good circles. Yeah. And like a whole crazy object, but the other thing that's in the way is the chill crazy. So
The water is free.
it's left turn. Why is there water?
Go back now, that's what I do.
Yeah, right, we're like, dang it.
Oh, guys, the conditions are right. This is. Yeah. No. It's not even there's water.
I'm just now realizing that local needed evolution.
That's just what we. We feel like. And then. You're like, oh, there's no way. Not one thing that works. I mean, if you want to set some rate, fine, give it a kind of
And then here's the like 3D print. Like,
they'll be dressed like. Face.
Yeah, that's true. You're right. One example, yeah, but for
South America, like all the colonies, all the super civilizations and stuff, and we don't. Really, you know, it's very interesting, some of it, how it
Yeah. Oh, yeah.
So actually, there was,
makes sense.
there's like another guy. He goes on Twitter, like, okay.
Python is now, but Carnivorous.
This is like, called the steroid law.
Very unrelated, like also like.
Yes, that's. Yeah.
But
That like the.
same as the natural.
Out.
Very big.
Yeah.
Really insane. We're all talking.
There's some.
many different people with somebody. There's really great. These are not animal things. These are right now. They do have. Oh, it's like very much like no, we can't even like figure out for mommy. Oh, yeah, like that's the mom. It's yeah, way too. I guess if you're fighting it, you want to do the other thing is that is, well, that is the internal nostril, so that when you breathe in. Yeah.
Please stop that.
So that is already the whole thing. But in these.
I think that's yours.
While it was alive, baseball. Oh my gosh, look, he didn't know it was a black light, like see it. There's
Yeah.
Yeah, the other thing that's just really cool, like.
We didn't go into that, we started after this. Already did, spring.
Maybe smaller, but it's not that.
I didn't even think of like, you know.
We all have.
Yeah.
Ripping off it. The other thing people are like, well, I didn't think you had my family. And so, yeah, they are like that. Not as good as it's like. I didn't love. I've always thought before, I'm like, you can start. I would think all. Yeah, it's crazy. You shut your mouth. But, all. So your team, or how they call it. Like, this one getting. Great, great. Of course, not like actual sort and like actual flags, like.
Yeah, I'm really excited about it's really nice having all that, that's where they are.
But there is, that is like the idea.
Even the team like that.
Yeah, no, I was, if I would do it, I would do beyond the 2,000, you know, some of the dinosaurs. Like, if I could, I was. Good was gonna be that.
From like 2.25 of fair.
I wasn't really. Maybe it's something I really like. Maybe you come back and do it in a million years and maybe I'll be. I don't want to do it. And more like things in like Well, in my family's house, he's on this. My family's house. Just running around, yeah. And like, we just let it like wait, it'll just like. Do their thing. One of my aunts said she's scared. Like the eldest in the house.
Do we have any, I'll come back together here. Any, answers to those, like, especially that bottom question? I'm just curious what, like, you guys, like, might have struck you about this, that you're like, that's legit. I just like also like people who make papers like this where they just go for it and they're like, let's just compare Gorgons to T-Rex and see what happens. They don't overthink it. Is that an appropriate comparison? Let's just do it.
I really liked, like specifically in the paper they had, that table just kind of explaining the physical differences between all of them. Yeah, that. Specifically like, what the serration is made of, like the tissues for the Smilodon is just enamel.
Yeah.
And like the replacement frequency. The like. Really
Yeah, identical width and replacement frequency. So I use this word back with you guys. Polyphyodont. So phyodonty is like this number of teeth sets you get in your life. Poly's a bunch. Di is 2. So mammals only have 2, right? Your baby teeth and your adult teeth. But reptiles usually have this, like, the ancestral character is like what sharks have, what fishes have. You just like replace teeth whenever you need to. And so it's interesting that mammals don't do that anymore. What I like is that the Dimetrodon, the one with the sail on its back, is just like a reptile, high replacement rate, right? That's what this is. Yeah, higher polyphyodont, high replacement. But the Gorgon's like a little less. We can look at enough fossils and cut up enough lower jaws to know that like the Gorgonopsian does replace its teeth, but not at the same rate as the Dimetrodon does or the T-Rex does. And then of course the Smilodon only has the 2 sets. Yeah, it's helpful, right? When you get like a bunch of stuff in like a table like that. What other things? I loved this. When I first read this paper, I loved it so much. That the dentin enamel junction is just like a brutal straight line in the mammal. And all those serrations that you guys just felt back there that are so fine are just like waves of the enamel. It's not looping structures like all these other amniotes have. That's really, to me, that's really interesting. Yeah, okay.
I kind of already mentioned it while we were back there, but that prismatic enamel was the thing I focused most on. And I was curious when that, like, at what point did that evolve? Is that just mammalia?
Might be just Theria. I don't know. Platypus, echidnas don't even have teeth anymore, so hard to say. And then platypus is the teeth that they do have are so weird. I have no idea. Wait, where do platypuses live? Australia. there's platypuses are so weird. They live in Australia for sure. They've got the most insane teeth. One of my favorite, like, just like, that's great, fossils, is like from Argentina, from South America, clear as day, gigantic platypus tooth all by itself that someone found and was like, so there used to be platypuses in Antarctica, South America, and Australia. Now they're just in Australia. But it's great when you find something you're like, well, you're not supposed to be here, but I know what this is. Yeah. One thing you guys can think about too, for just for like mammal evolution, synapsid evolution. Here's the hole for jaw muscles. Here's the hole for jaw muscles. Here's the hole for jaw muscles. So mammals are pretty powerful jaws ancestrally, which is really cool. All right, the one thing I want to say, unless anybody else has things, where's water come from?
No.
Which is so great. I wish you knew how deeply I wanted to be like, whoa, sorry, Dr. Pradhan. We're going to Earth formation.
This is a precursor question.
That's how I get fired. Okay.
So this kind of goes more to like the ecology side.
Yeah.
We talked about like tyrannosaurs, like clearly they have like similar sized teeth to like the saber-tooth and saber-tooth cat, but the skull of saber-tooth cat is like way smaller. Same with the gorgon.
Mhm.
And so we were thinking like, is that saber-tooth an adaptation to take down megafauna prey?
Oh, yeah.
Is that this
Yeah.
a specific character that they evolved so they could get to the vital?
For sure. For sure. So one of the things I want to talk about was like the ecology of these animals. Luckily, saber-tooth cats are like, they're just cats, and we know a whole lot about cats, and there's plenty of cats we can look at today. And so one thing that's really cool is there's been enough functional studies. So this is gorgons over here. There's been enough functional studies of these animals that we know how they hunted. So Smilodon, even for a big cat, is super ripped and has humongous arms and humongous hands and really long claws and very powerful anterior body. When they go extinct, the giant sloths and the mammoths go extinct with them. Probably these are what actually go extinct, and these are their prey, is what we understand it to be. There's tons of saber-tooth cats. They exist for like 10 million years on most continents. And so we know a lot about their evolution. And the biggest, gnarliest saber-tooth cats are associated with like giant sloths and elephants and sometimes rhinos and giant camels as like their prey. And so these are mammals. This is an African species, so these aren't huge sabers. This isn't Smilodon. This is not the species you saw, but they are sabers. And how we think they all would hunt is like they're not particularly fast, so like ambush predators, very heavy, bring things down. And because these canines are so valuable and you cannot break them, it's like once the animal's down and exhausted, I don't know if you guys are in the mood to do this, but I encourage you to if you want to. Like Google lion hunts and just watch a bunch of lion hunts on YouTube, because like lions don't like kill you if you're a buffalo or a juvenile elephant or a giraffe or something. They like get you to the ground and they like bite your nose and bite your mouth and they suffocate you. They bite your windpipe, they suffocate you. That's how a lion kills its prey. And so people think on these big animals like elephants or giant sloths, Smilodons are sitting there with like precision jugular carotid, bites kind of at the end. Precision instruments at the end. You don't run and bite with these, you're going to break them. You handle the animal down to the ground. It's exhausted, which is just like what a lot of big cats do today. And then this moment happens, which is really gnarly. The same thing might be true for gorgons. We're not 100% sure. I know I talked about this with some of the groups back there, and apologies if you think this is like so gross, but the cats process meat. Once that elephant's dead, they're going to just sit there and use their carnassials to like rip off strips of flesh. They process them a little bit, they swallow them. The gorgon can really open its throat in a pretty big way and has almost no teeth behind the canines. Very rarely are there any. And so it's definitely just like fully taking bites. There's one of those pliosaurs having a terrible time. And just swallowing that meat like whole. So it's like almost like kind of like a gator kind of situation, like throwing the meat back like that. So it's not at all like the same food processing between the two. But yeah, so I guess your original question was these animals as megafauna specialists. That's absolutely what we think. Because like the thing that also is interesting is that saber-tooth cats are part of the landscapes of Europe and Asia and Africa and North and South America up until very, very, very recently, up until people show up in all those places. And so in India, there's just normal tigers with saber-tooth cats. And in Brazil, there's just normal jaguars with saber-tooth cats. And those animals are eating like deer like mid-sized prey, and they don't go extinct. But the saber-tooths go extinct, and then the elephants and giant sloths, giant camels, rhinos in Asia go extinct, and then they might lose their prey. So it's almost like they're like the top echelon of like cat in their habitats, but they're not the only ones. In Idaho, we've got two kinds of saber-tooth cat, a straight up lion from here, like Pocatello, we have the fossils, and then there's like normal mountain lion and like black bear that are just like part of that ecosystem. Now they are the big predators. I put this up here just in case you guys are interested. So the last author on that paper you read was Kirsten Brink. So this is her in 2015. This is the paper that got this research started. She's a Canadian, and the Canadians have tons of good tyrannosaurs. So they developed this humongously cool paper talking about how dinosaurs evolved their serrations. And then that's what made my friend Megan like email Kirsten and be like, I got Gorgons with serrations. I'm like, that's just like how science happens. It's like friends talk to each other. And so if you were interested at all, this will be on the slides, but there's like a whole like Tyrannosaur specific paper on how they evolved their serrations and like the adaptations in dentin and enamel they seem to have gotten within the context of dinosaur evolution. But anyway, I won't. I'll pull up because it's pretty obviously paleontology and I shouldn't do it. But you guys can know about it. All right, so let's take a break here for a minute. So Dr. Pradhan should be here kind of any second. And hilariously, stop thinking about, oh, hey, how are you? Why am I'm like, I'm birthday, so I was like, where are you? How long have you been here?
I guess I came with the previous slide.
Great, so
Yeah.
quiet. I really was like, I saw all that, I didn't even need to.
Yeah, sorry, I don't know what to say.
Right, well, what are these? I'll stop talking, what are these?
These are just, these forms to make sure that, you know, you're.
Where are
kind
you
of
taking
comfortable
us?
with
Where are you taking us?
Stuff
Where are you
in
taking
the
us?
fish room.
The fish room.
This is my quiz.
Yeah.
I thought you would already talk to them about it.
Well,
So
I said we're.
Before entering the animal facility, you need to sign this waiver.
Let me know if you need
And
more.
there are different facilities that require different kinds of waivers, so.
Oh my gosh, we'll stop talking about teeth and start talking about fish
Anatomy.
parts.
You made me think about my work in a different way.
Oh, man. Yeah, how long have you been here?
Oh, no, not this, but because of, while working on this stuff.
Okay, what can I pull up? Or do you want to, how do you want to do it? Okay. I'm going to